Hi there. I'm Tom Field. I'm Senior Vice President of Editorial with Information Security Media Group. I'm delighted to welcome you to today's session entitled End-to-End OT Patch Management. Your presenter is John Livingston. He's CEO of Verve Industrial. Now, before I turn this over to John, let me give you some background on our session. Software patching is often thought of as a basic cybersecurity process, and on the surface, it appears to be straightforward. Simply apply updates to your systems. But as it turns out, patching is not so straightforward after all, especially in industrial IT environments. In fact, it's likely the single most time-consuming task that the North American power industry faces in adhering to regulatory expectations. So in this session, you'll learn how automation plays a role in an effective patch management program, how to prioritize your most at-risk vulnerabilities for patching, and how to scale globally while enabling local actions on endpoints. A little bit about my organization, Information Security Media Group. We are nearly a 17-year-old education and intelligence firm global. We're based in Princeton, New Jersey in the US, and you may know us, of course, by any of our 35 media properties, including Bank Info Security, Healthcare Info Security, and Data Breach Today. In all, we reach an audience of over 1 million security and technology leaders globally. We give them a daily diet of news, analysis, research, events, and educational programs just like this one. A few notes of housekeeping. If you have any questions for John anytime during this session, you can submit them via the chat window on your screen. Now, I may not be able to get to every question, but here's our promise. Any question we don't answer today, afterwards, we'll get a response directly to you via email. Also, should you encounter any technical issues while viewing today's webinar, take down the email address you see on your screen. If you write to webinars@ismg.io, we've got support staff standing by to help. And a reminder, today's webinar is copyrighted material meant for today's session and individual study purposes only. If you'd like to use any of the information presented today, or if you're looking for customized training materials, please contact us. Let's meet our sponsor today, Verve Industrial. For over 25 years, Verve has helped clients improve their OT and ICS security maturity. Their expertise overcomes the challenges of secure and reliable IT and OT systems. Verve Industrial Protection offers the only endpoint protection platform built for OT ICS cybersecurity. They combine the platform with leading ICS OT engineers who provide turnkey support every step of the way. They are your partner in your OT ICS security journey. And let's meet John Livingston. He leads Verve's mission to protect the world's infrastructure. Of course, he brings 20 plus years of experience from McKinsey & Company, advising large companies in strategy and operations. He's committed to helping clients find the lowest cost and simplest solution for controls, data, and ICS security challenges. With that, let me turn you over to the very capable hands of John Livingston. John, the stage is yours.
Thanks so much, Tom. Really appreciate it. Great to be with you. Good to be with you here today. So as Tom mentioned, we're here to talk about effective and efficient OT vulnerability and patch management. How do we achieve what sounds like a very difficult task within the OT world of making sure that we are patched, making sure that we are essentially secure at that endpoint layer. And so, without further ado, talk through a little bit of what we're going to talk about here today. First of all, the importance of OT patching vulnerability management is growing. And we'll talk a little bit more about why that's true and what's changing out there in the landscape. Number two, there are some big challenges. So we're not hiding this, right? We understand that this is not the easiest thing in the world to do, whether it be effectively, actually achieving the results, or efficiently, right, without having huge amounts of labor going to this. So we're going to document those challenges, and then we're going to talk through an approach that we found successful over the last 15 years or so of actually being able to do this in a way that is both safe for operations as well as efficient and effective from a resourcing point of view. So just in terms of background, I think it's important to note where we are in the threat vectors happening in the industrial environment. So just as some data, as we think about how risky and how much we are in the crosshairs, manufacturing is now the #1 most targeted industry. The 2022 data is not fully available. For the first half of 2022, manufacturing remained as the most targeted industry. Energy has moved a lot from where it was in 2019, over the last couple of years. The point here is that attackers have shifted their focus towards the industrial environments, and in large part because of ransomware, because they discovered that this is a very profitable enterprise to target manufacturing and energy, because these are industries which can't have downtime given the economics. At the same time that this is happening, that we are under greater targeting, we are also seeing a significant growth in the number of public vulnerabilities. So this data shows the growth in 2020 and 2021. We're just about to release our 2022 data in a week. And the results are essentially the same, meaning there is roughly the same percentage growth in the number of ICS advisories coming out of CISA, the number of CVEs in those advisories, and the average risk score of those vulnerabilities, CVE being a vulnerability. Point here is that as researchers and frankly, bad actors dive into these industrial control systems, they start to find more and more vulnerabilities hiding in the software and the hardware that is out there. And so from an operational point of view, we are left with significant challenges. In addition, insurers are also realizing this problem. And so if you go back 2 or 3 years ago, insurance was relatively easy to get, cyber insurance that is, and really wasn't very focused on the OT or control system side. Now, each time, number one, the prices for insurance have gone up quite substantially as ransomware has been more rampant, but also we've now found the insurance companies are requiring very specific applications for OT cyber, where there's actually a supplemental application that you need to fill out for OT. And when you look at that, you see that they're actually asking very specific questions around vulnerability and patching. Are you updating these devices? And then not just are you yes or no, but describe how you're doing it. Describe compensating controls you have in place. And so we are under attack. Insurance companies are recognizing this at the same time that these vulnerabilities are frankly exploding. And so this is putting a significant amount of pressure on OT personnel to be able to deal with all of this. How do I handle thousands of new vulnerabilities each year when I'm now being asked by insurers, and by the way, therefore my board of directors, to start managing this stuff similarly to the way I manage IT security, all at the same time while I've got to run that paper mill 24/7, and I've got to have a turbine that's running all the time, et cetera. So the need is growing. The need for some way to address vulnerability and patch management is growing, but there are significant challenges. These are just a few of them that we hear and we see regularly with organizations. The first being time consuming, right? All right, if you want me to patch these things on a regular basis or update firmware on a regular basis, this is going to take a lot of time. And frankly, I don't have the controls engineers available to do this. Secondly, well, it's great. You say I've got all these patches, but vendors aren't going to approve those patches, meaning I've got a control system that is provided by Yokogawa or Honeywell or Emerson. I can't just apply any patch. I'm going to have to take what the vendor has approved and tested on their environments. And so a lot of things I may not be able to do. And kind of going along with that, the last time IT tried to apply patches in my environment, they tripped the plant. So we're not going to just let IT come in here and apply any patch they want. In many cases, I don't even know the patches that are required because there's no public source of these patches. It's not like, I just pull them off of Microsoft, right? I've got lots of vendors that may not, supply me patches on a regular basis. So which patches are going to be required? The complexity of updating firmware when I have to, think about updating the whole control system, maybe to do that. Rebooting issues, can't get access to patches. given OEM relationships, et cetera. There are a lot of challenges. We're not saying that isn't true. And the question is, all right, well, how do we deal with these challenges? Because we've got to do something, because we're being forced to by the environment. We also find that even when we are supposedly patched, we often miss significant vulnerabilities. And so what this chart shows is an example of the OEM vendor comes in and patches the system, patches it with their approved list of patches. And what we find is, and then we go in and we use our software to identify what vulnerabilities still exist. And you find that significant number of vulnerabilities still exist. Why? Well, it may be that patches weren't approved by that vendor. It may be that there's software on that system that the vendor didn't look for in their patching. In other words, it was software that wasn't put on originally by the vendor, Adobe as an example. And so therefore it's not patched. And then lastly, there may be some end-of-life systems out there that just are no longer patched. And so even if we go through the process of patching, we can still miss significant vulnerabilities if we're not being really thoughtful about how we're assessing those patches, reviewing them, finding them, etc. And then lastly, on the challenges side is this IT/OT, split, right? There is in IT a very standardized process of how we deal with patching, right? We're going to scan assets using a vulnerability scanner. We are going to then centralize patching using some tool, and every Tuesday your laptop is going to reboot at some point, and you're going to get the latest patches. You're going to have some central visibility to what patches are still missing, et cetera. We've been doing this for 20 years, right? When we switch over to OT, right, we have to have continuous uptime. So we can't scan these things with a vulnerability scanner, right? For those of you who have tried that, you've probably ended up with PLCs that are bricked, et cetera. We need to have control over those patches locally. Can't just push the patches from 2,000 miles away. We need to have people with eyes on glass of that control system to know when is an appropriate time to update a piece of software. And we have to do that in many cases locally without a lot of access to the tools and the visibility. So there's just a fundamental difference as we think about how we're going to have to address patching. And the reason for the little planets here is, right, you've got IT is from Mars and OT is from Venus, right? They're literally from two different planets. They talk different languages around this topic. So finding a way to address that is key. Okay, so we've set up the challenge, right? We know we have to do it. It's hard. It's hard. The good news is there are some ways to do this. And so the rest of the conversation today, we're going to focus on, okay, so what can you actually do about it? So the way that we think about driving to vulnerability or risk management is across a three-phase cycle. And the first is around assessing. So identifying and prioritizing those risks, identifying vulnerabilities, what patches are missing, et cetera, and developing a roadmap of, okay, what are we going to do to fix this? Then comes the phase where we actually start to apply that remediation, right? So how do I go from almost all the time when you do your initial review of patches and vulnerabilities, there's thousands of them. Okay, so how do I catch up? How do I do an initial rollout of patches to catch up? And then over time, we need to maintain, right? New vulnerabilities are released on a regular basis, literally every week or more often. New vulnerabilities are coming out. We need to assess those risks within our environment and then decide on what is the remediation that we need to take as we go forward to maintain. And so as we think about how we're going to address patch and vulnerability management, we need to think about each of these phases and think frankly about how we're going to automate and how we're going to use a technology to essentially address those challenges that we mentioned earlier. And so when you think about applying technology or automation, there are ways that it can be effective across all three of those steps. So first, let me talk about assessment. We call this a technology-enabled assessment. meaning applying technology rather than manual data collection to do vulnerability assessments across global sites. Many industrial organizations have sites all over the world, right? To the idea that we're going to be able to manually collect data from individual sites and assess the patches, et cetera, is almost impossible from an efficiency point of view. So first, leveraging technology to gather that data without risky scans of the environment. Number two, using centralized technology to provide prioritization of the risks, right? To analyze different risks, and we'll talk about how to do that, but essentially taking that automation and applying it to risk management. And then scoring risks. Which ones are the greatest? How do I prioritize those patches that I need and those vulnerabilities that need to be remediated? The next step then is to actually do something about this. So to actually take action, to manage those assets. And so that requires, from an automation point of view, leveraging technology that can automate the creation of patch lists, can integrate those vendor-approved lists that we talk about, can also automate collection of any approvals that go on internally. And then from a remediation point of view, it's got to allow that operator at the site or perhaps an operator remote control center who has understanding of that control system. It needs to give them the automation tools, but allow them to drive the timing, the approach to testing, et cetera. Because we don't want to be in a world where, great, we can automate the remediation, and so we just push patches without an understanding of the actual process as it happens. So that's the second piece, finding a way to do remediation safely within OT. And then lastly, maintaining it, getting a real-time visibility as new vulnerabilities emerge, being able to do real-time risk scoring to know, okay, does that matter? Does it not matter? How do I prioritize that? And then creating a regular rhythm where we can remediate those patches and vulnerabilities on an ongoing basis. And so technology or automation can help across this sequence, and it has to be blended with that OT specialized knowledge of the folks closest to the process. So we'll dive into how that works. So first, on the assessment side, we find that what we call a technology-enabled assessment offers some big benefits to the traditional kind of manual vulnerability and patch assessment. Right. So the first is, by using technology, we can gather what we call a 360-degree score, meaning we're not just looking at, okay, what patches are missing or what vulnerabilities exist, but we can also look at what are the users and account risks on that system. What's the AV status, antivirus status? Is it up to date? Is it not? What does the network protections look like? What is the configuration of devices? We'll talk more about this, but the idea that we can start to model out different risks to put risk scores to things to allow us to prioritize. The second is that by doing a tech-enabled assessment, we can then get enterprise visibility. Right? So one of the biggest challenges with patch management and vulnerability management is if I've got 50 manufacturing facilities or production facilities around the world, I need to have 50 different people trying to prioritize what patches to do. It's just not feasible. And so by bringing all of that data centrally, I can then have a small team of people who really understand the security and the risks to prioritize those patches and vulnerabilities. The next is that a tech-enabled assessment uses technology that then accelerates your ability to remediate, right? Because when we use technology to assess, we can use that exact same technology to remediate those risks as we find them. And we'll talk more about that. Next, a tech-enabled assessment means that you can have real-time updating of those vulnerabilities and patches rather than a manual approach where, okay, each time I want to do another assessment, I'm going to go back out to a site, I'm going to look at it again, I'm going to try and manually gather data from assets, et cetera. This way, literally every 15 minutes, you're getting updated views of what is my security risks. And then lastly, it's built, this technology that we're talking about is built by control system engineers. As Tom mentioned earlier, Verve's been in this business for over 25 years. And we started as a control systems engineering firm. So we understand these control systems. So the technology that we're talking about here is not an IT scanning technology. It's a specific OT technology that allows us to do this safely and effectively in OT. So a range of benefits. Those benefits start with this technology platform I referenced, right? The ability to gather an asset inventory that provides the level of depth necessary so we can see vulnerabilities, we can see patches, we can see misconfigured assets, we can see users and accounts, etc. The ability to bring this data together into a single platform. It is this technology that allows us to begin the patch management process in a way that will drive efficiency down the road. So I mentioned this 360-degree risk analysis, and this is really a key part of getting effective and efficient patch management. If we just put patching in a silo, in OT, it will not work effectively. We have to look at a 360-degree risk because we may not be able to patch every vulnerability, right? In IT, yeah, patch it, great. In OT, well, the vendor doesn't approve that patch, or that PLC can't be upgraded right now because it would require an upgrade to other parts of the control system that's cost prohibitive. So we need to understand the full risk to understand what else we might be able to do if we can't patch that, or alternatively, how risky that asset is that we really, really have to get to that patch right away. And so that looks at vulnerabilities. It looks at missing patches. It looks at those insecure configurations. It looks at users and accounts. In other words, do we have a bunch of dormant accounts? Are our accounts being shared across devices? Do we have anti-malware in place? Is that AV signature updated? Do we have whitelisting, application whitelisting in place? A great compensating control if you can't patch right away. Do we have upstream network protections? So oftentimes we may not be able to patch, but we have a very strong firewall or even a data diode upstream of that. What's our backup status? Before we start patching, we better know if we have a backup to that system, because obviously you may need to roll back that patch and you want to make sure you have a backup. And then finally, how critical is that asset, right? Operationally, because as we think about prioritizing, we need to understand how important that asset is. If it's not critical, maybe that patch doesn't need to be applied right away. But if I've got a critical system to my operation and a critical patch that's missing, I may need to prioritize that faster than others. And so bringing all of this data into one place is absolutely critical to our ability to do effective and efficient patch management. That starts with really deep asset inventory. You need to not just know, okay, I know the IP address, I know the MAC address, and I know maybe what OS version is running. I need to see all the assets. I need to see through backplanes, PLCs in racks, behind racks, etc. I need to not just know the OS version. I need to know all of the installed software. What are the applications? I need to know the patch status on those. So yeah, great. I know it's a Windows 10 version X, but that doesn't necessarily tell me what patches are missing. I need to know the status of that antivirus and whitelisting, etc. The only way you have to get deep into these assets to be able to understand these risks, to do what we're talking about, which is that 360 view. So as an example, right, the first step is understanding what vulnerabilities exist. So if folks haven't done vulnerability assessments and patch reviews of their OT environments, they are going to find the first time they do this, literally thousands of vulnerabilities. Those vulnerabilities will be across Windows devices, across HMIs, servers, that type of thing. They'll be on PLCs, they'll be on controllers, they'll be on relays, switches, etc. Because these systems traditionally have not been patched. And so this is a somewhat typical environment, right? You get thousands of high criticality vulnerabilities. And then we start to drill down, right? So we say, okay, let's look at whether or not there is a known vulnerability, a known exploit for that vulnerability. So let me just aside quickly here. As we think about doing patching, we don't just want to look at, oh, well, that vulnerability is really risky. So that software vulnerability that came out of the National Vulnerability Database, very, very risky, CVSS of 10. Okay, but then the question is, does someone have an exploit for it? Meaning, is anyone come up with a way or shown a way in public that there's an actual exploit, a way to take advantage of that vulnerability? And so as we think about prioritizing, we want to narrow down our focus to the extent we can. And one of the ways of doing that is looking for those with active exploits, meaning there's someone out there who's actively exploiting that vulnerability. One of the important parts of this is, as you look at this within the OT world, most of those with active exploits sit on your HMIs, your servers, your workstations, and that sort of thing. Most of the vulnerabilities that have been discovered on the embedded devices don't yet have active exploits. And so as we think about prioritizing, we're likely going to lean towards prioritizing those patches and those vulnerabilities in the OS-based devices, the Unix, the Windows, the Unix, the Linux type environments. And then we'll want to look at, okay, are those critical or not? So in this case, we've gone from, literally 6,000, 7,000 vulnerabilities down to, okay, there are 37 critical vulnerabilities where there is a known exploit. And we start to be able to drill down to which of these do I really have to go after first. Secondly, then, we need to know, what about the patches? So those are vulnerabilities. Now, what patches are missing that might address those vulnerabilities? And this is just a dashboard that comes out of the technology platform we were talking about. And again, 3 sites, different geographies, number of patches that are missing. But then again, the ability to narrow down to which patches are most critical, right? So I got critical severity patches, and then I can start to monitor, how am I doing, right? Oh, well, I've got 6,600 missing criticals. But in OT devices, I've got 1,900. I can start to measure how I'm doing on the number of missing patches that we have. So patching, I mentioned this 360-degree view, right? So when we look at vulnerabilities, we will find, as I said, lots of vulnerabilities and missing patches. However, we also have to take into account whether or not those vulnerabilities might be addressed through configurations. Let me give you a simple example of this. We identify vulnerabilities on a Cisco device. That vulnerability is revolving around an HTTPS insecurity vulnerability. But I know that I have disabled that on all of my Cisco devices, and I can measure that, and that's what this is showing. So I'm going to look at the configuration across all of the devices in my environment, and I'm going to have a set of checks, a set of compliance checks on those devices. And what I'm going to be able to do is to look at these vulnerabilities and say, okay, I have that vulnerability, but is it somehow mitigated by the fact I have a configuration setting on that device that reduces the chance that that vulnerability can be enabled? For instance, the SMB vulnerability, I have disabled SMB on those devices. And so by looking again deep into the asset, not just at patches and vulnerabilities, but at other things like configuration settings, I can start to see what mitigations I have in place against patching. The whole idea of this is, how do I narrow down? How do I focus? I'm going to have thousands of vulnerabilities. I can't patch everything. So how do I narrow down the focus? And this is another way of limiting and focusing on those patches and those vulnerabilities that are not mitigated in some other way. And so to summarize that, the way that we think about being able to drive efficiency and effectiveness is to automate the risk scoring. And by automating this, we can start to do that prioritization I was just talking about around, okay, I know it's a vulnerability. It may or may not have a known exploit. It may or may not be mitigated by configuration settings, et cetera. And I can then put that into a model. And we've built these models that use machine learning to identify which are the riskiest assets and vulnerabilities that we really have to address right now. So it starts with the asset type. What's the criticality of that asset? Is it a safety system? Does it control critical processes, et cetera? We'll then look at what are the risk So you get the criticality of the asset, you then get risk components. So what are the risk components? Vulnerabilities, configurations, user account status, et cetera. All those things that we talked about in that 360 view, we can then include those and we create a unmitigated risk score, meaning, okay, these are the risks that are in my environment. These are the unpatched vulnerabilities. And then the model can add in those compensating controls. So if I hardened that configuration, do I have application whitelisting on that asset that locks down the ability to deploy new applications? On and on. And eventually you can come up with a risk score. And this is where the automation of technology allows us to really get focused on, okay, which are those which have the highest risk score? And I'm going to focus on those assets and those patches to go after. So the whole idea here is, as we think about an assessment, taking this sea of vulnerabilities, which will be there, and focusing, using technology to enable us to get really pinpoint on which of those are most critical to remediate in the near term. We can then model different attack paths using those risk scores to understand how an attacker might actually come in to that environment using different steps in the chain. And again, hitting at those areas where the greatest risks are. So how do we then move to starting to remediate this? We talk about this as a think global, act local approach. So what we've been talking about so far is that think global piece. We're aggregating all of the data from all of these different risks and sites into one integrated platform that allows us to scale the analysis that we just talked about. And then as we go to actually remediate those risks, it's all about acting locally. And what we mean by that is, this is where bringing in the plant IT, the engineering, the folks who understand that process, they come in to actually help us act, to remediate. So the platform takes this up, analyzes it, and then it distributes it down so that those local actions are automated, but in control of the people who know the process best. This architecture is absolutely critical in our view to enable you to get the efficiency you need while ensuring you have the OT safe practices that are critical to keeping operations going. So it's typically a 6-step process to the remediation. The first is updating that baseline, the inventory baseline, and your vulnerabilities and patches, right? So that we've talked about. The next is then to review and prioritize those, and then to develop remediation and mitigation plans, meaning, okay, these are patches I need to attack right now. These are other ways I may address that patch, even if I can't deploy it. So let me give you an example. You have a patch that needs to be deployed to a Windows device, but your vendor, Yokogawa, Emerson, whoever, hasn't approved the patch. So you can't deploy it right now. It may be deployable down the road, but not right now. So what this step is about is, all right, what are the mitigating steps I can take if I can't patch right now? Perhaps there's a configuration setting I can include on that device that reduce the risk. Perhaps there's application whitelisting. If I deploy that application whitelisting, that will reduce the risk of someone being able to deploy a new piece of malware, run a new piece of malware on that device, even if it's vulnerable. A variety of different alternative mitigations that we can document and put into our plan. We then go test and deploy, right? So we test those patches. Obviously, we want to run them, let them have soak time in our control system, and then automate that local control that we talked about before. And then finally, demonstrate and document the success, meaning monitor whether those patches have been deployed or those mitigating measures have been deployed, and then document that in your reporting. That all then starts again, right? It's an ongoing process that goes through. So these are the basic steps that we go through. How do you develop those remediation and mitigation plans? First of all, defining, what is the ability to patch that and what's the urgency? So we've talked about that. Number 2, what are those alternative mitigation strategies? As I mentioned, application whitelisting, updating AV, et cetera. Third, assigning the mitigation and timing until you will patch. right? So making sure that as we put that mitigation in place, we don't forget that the patch has to be deployed, and we're going to set a timeline. Okay, in 6 months, we're going to deploy that patch when we have an outage, let's say. And then we monitor the mitigation. So let's say our mitigation is a firewall. So we've put a firewall in place with a very tightly locked down set of access control lists. Then we got to monitor that. Right, we got to monitor those access control lists, and we'll talk about that in a second. And then obviously eventually resolve at the appropriate scheduled time to remediate and patch that accident. We talked about how do you prioritize specific patches, right? The technology can really help us do that as well. So I'm going to focus your eyes on the bottom of this page for a moment. So one of the things that we can do is we can say, okay, we have all these patches. So those patches are applicable to our devices. And then you look across and see how many of our vulnerabilities could be addressed with that single patch. And so you can see on this first patch, if we applied that patch to 2 assets, that patch, because it's a cumulative Windows patch, could address 172 or 7% of all of our total vulnerabilities in our environment. And so as we think about focusing on the remediation, focusing on those patches that can knock off a bunch of the security risks at once is a big win for us. And then the right-hand side of this shows how that technology also allows us to bring in approved patch baselines. So, Emerson approves these patches. Great. Let's bring those into the database so that we know what's been approved by the vendor and we don't patch something that wasn't approved. But at the same time, we can track that as a baseline and say, okay, but here's what wasn't approved so that we can always have that sense of what's not been approved. Big question comes up often around testing. And so this is typically the way we approach testing. So reviewing it with the list from the OEMs to the extent it's available in that list. Comparing then to the known vulnerabilities that we've talked about. Downloading those into some form of a safe zone, typically through a proxy or a DMZ. Ensuring that the hash values of the patches match. This is a big issue of making sure that we have the right patch and that it's not been delivered to us with malware included. Testing those on non-critical systems and then letting them soak for a period of time. Ensuring all of those devices that we're going to patch are backed up. Backups are key. And then working through the rest of the deployment process before confirming. But that's just the remediation part. So we've gone from assess to remediate. Now we're talking about maintaining. How do we maintain this? How do we use technology to maintain that security that we know exists? Well, so a variety of ways to do this, but one of the keys is that we have to avoid rot. I mentioned before that we may have a compensating control on our environment that is a firewall in place that has a certain set of rules in place to protect our systems. Well, we got to monitor that firewall. We got to identify, is there a change to the configuration of that firewall that somehow reduces the protection that I built on that? I want to be able to, identify and eliminate those accounts and passwords that somehow arise in the environment. You have an outage, vendor comes in to do maintenance and they add new accounts. All right, I want to know that. I want to be able to remediate that. Oftentimes folks will come in and they'll put TeamViewer on something for some reason. Okay, I want to see that immediately, get rid of it if that's applicable. And I could go through a range of these, but the point here is that whatever we do in patching and vulnerability management, we need to make sure that we're monitoring the risks, monitoring the vulnerabilities, certainly, like we've got here on the bottom left here, but we also have to monitor the mitigations we put in place, right? Monitor the firewalls, monitor the AV status, monitor the backups, because if we've got a mitigating measure in place that we're using so we don't have to patch, we need to make sure that that security control we put in place doesn't quote unquote rot or change over time. And that, from a monitoring point of view, we can then literally monitor on a day-to-day basis how I'm doing against my vulnerabilities. So great, we got a bunch of vulnerabilities. We go through a patching cycle, we're good for a while, and then boom, right? The next month, a whole bunch of new vulnerabilities are released and we're back up again. And so being able to monitor how I'm doing on vulnerability and patching allows us to go to executives and show them, back to the whole insurance discussion up front, hey, we are making progress. We are demonstrating improvements over time on our vulnerabilities and our patches. And so finally, in summary, we recognize this is challenging. We recognize that, but we have to do something. This approach that we've just laid out, we have found saves about 30% of the cost of doing the assessments. So if I'm going to go out and do manual assessments of my sites, how do I get lower cost of that? Using a tech-enabled approach drives a significant reduction in that. But then secondly, we also can drive a significant maintenance cost difference. And this is where the big costs are, right? It's one thing just to do an assessment, but then I've got to go in and remediate things. I've got to maintain those over time. And this is where using that Verve's technology approach really drives the savings, because now I am doing that automation of risk assessment all the time, right? And it's literally being automated and calculated on a real-time basis. And then as new patches and others are released, I'm building that automation to allow those OT practitioners to do the patching. And so this process that we've talked about here not only is effective and safe for OT, but it also solves that biggest problem, which is how do I reduce the amount of resources necessary to maintain a consistent vulnerability and patch management program. So with that, I'll draw the comments to a close and look forward to open to questions and discussions of other topics here. So Tom, back to you.
Excellent, John. Thank you so much. Appreciate your presentation. And a reminder to our attendees, if you've not submitted questions, do so now. Can't get to every question, but those questions we don't get to in the course of this session, we'll get responses back to you via email. John, first question I have for you. What is the process to coordinate patch rollouts between IT and OT?
Yeah, it's a great question, Tom. So the IT will typically have a process that they put in place that's been running through their ITIL or other process for years. One of the keys in coordinating this is making sure that they understand that patching in OT needs to consider not just patches, but the rest of those mitigating controls. And so the biggest difference, maybe, or the biggest way of coordinating is communicating that, okay, this is going to be a different process. We're going to need more information as we do this, but then giving the IT teams what they need, which is clear reporting on how I'm doing. Because IT wants to know, hey, how patched am I? What vulnerabilities exist? And so a key to this is giving them what they want, which is reporting, et cetera, but also explaining to them there's a way of doing this in OT that's going to be slightly different than you do in IT.
Next question I have for you, John. How do you ensure patches do not disrupt operations? I bet you hear that frequently.
Absolutely. Patching can be incredibly risky to operations because if a patch is not approved by a vendor or has been tested, you can stop a process, no question. Or alternatively, you update a firmware and that firmware update doesn't go very well, and so the device stops. The way we do that is twofold. So the first is we do absolutely integrate those vendor approved patch lists. That's a key step in this process, right? And most of our clients, they'll have a dozen or more OEM vendors, and they're trying to manage these lists across spreadsheets. So the first thing, get them in. And then if they're in there, that's terrific. But we still go through that testing process I mentioned earlier. We still want to put those on a couple of basic systems and monitor that for a period of time. And then the last thing I'd comment on is backups. If you don't have a consistent backup program, you probably aren't really ready to start doing your patching.
John, last question I've got time for here. Does Verve manage application whitelisting?
Yes, we do. We do. One of the key compensating controls that you can put in place is application whitelisting. Absolutely. One of the key elements of Verve is to be able to manage that application whitelisting, make sure that it is in lockdown, making sure that you're not adding new applications as people go. Absolutely.
Very good. Again, I'm grateful for your time, for your presentation. Thanks also for answering these questions.
Thanks, Tom. Appreciate it.
course, I want to thank our attendees as well. We know you took time out of your day to attend this session. We're grateful for that. And I do hope you're walking away with some new ideas, new insight to help you and your organization tackle the OT security issues we've discussed here today. As always, I look forward to seeing you again at one of our upcoming events. And until then, for Information Security Media Group, I'm Tom Field. Thank you for giving us your time and attention today.